Let me open the project with the Visual Studio Code. So opoverload fstack, that is the one. Let me first erase all the test code in main function. And let me first show you why we have to do operator overload. So let me create the fstack object with the 5 array size, F1 push, 5, 6, 7. Let me have those 3. And like some other integer type of any other case, we could have another f stack with a different size, and then let's do f2 push 10, 11, 12, 13, 14, 15, something like that. So if we have two variables of the same type, then we may do like f2 is f1 assignment. So if f1 and f2 are integers, we know that the contents in f1 is copied into f2, so f2 and f1 have the same value. So that's what we normally do if f1, f2 are integer or double and like those types. But what if we have a class type, our own class type like fstack? Then what happens? First, let's just see if this assignment is allowed in a user-defined class. So let me open the terminal, and then let me delete a.out and .o files. Then let's compile. So it compiles okay, and then it runs okay. It's not running okay. It is actually some problem there. So here, let me show you why this has a problem. Actually, this explains why sometimes we have to give the operator overloading. So at this moment, let me set the breakpoint debugger and start. So I have F1 and F2, and then there's array. This is array and the like. So we have two array fstack objects f1 and f2, and then p array is pointing to the data and so on. So that's what you got. But after we do assignment, let's do step over. What we see is f1 is pointing to an array at this address, and f2 p array is pointing to the same address. So we have some problem. So what it does is as follows. So prior to executing line 21, so at this moment we had f1 object, and then which is a p array pointer is pointing to dynamically allocated array. 5 is array size, and then using this one we did a push 5, 6, and 7. 5, 6, and 7 we did push, and then here top of the stack is 0, 1, 2 is the one, and then at this moment f2 is created, and then p array is pointing to dynamically created array, and then we had the push 10 through 15. So this is index 0, the 10, 11, 12, 13, 14, 15 is there. And then top of stack is 5, which is 0 through 5 is there. So that's what we have. Now assignment in C++ for class variables, class objects like F1, F2, and fstack, any user-defined class. Assignment is defined in C++ such that it's a member-wise copy is made. Member-wise copy is a definition of assignment. So what it means is that if I do F2 equal F1, in F1, each member is copied to the corresponding member in F2. So in F1, I have a TOS, which is 2. So 2 is copied into F2. And then P array is currently pointing to this element. And then that address is stored here. That is copied into F2. So F2 is no longer pointing to this array, but pointing to the same array. So that's what we observe that. So F2 P array, F1 P array is the same thing. The top of stack TOS is copied, size is copied. So each member, so in fstack, P array, size, TOS, each member is copied. So member-wise copy. So assignment ends up sharing the array by two different objects. So that causes a problem. So what we really intend was the copy, the data in F1 stack, 5, 6, 7 are copied into here, something like that, not sharing the same array, but it ends up sharing the array. Because of that, what will happen is that when F1 and F2 deletes allocated memory. So at this moment, let me do step into. Then fstack delete the P arrays executed. So step into. So first F2 is freed. Now F1 is freed. Then at this moment the P array, since the P array is pointing to the same array, so the array is tried to be freed one more time, and then that error occurs. So that was the error when I run the program there. So that causes a problem. So when I run this program, I had the error that the pointer being freed was not allocated. So that is the problem. So the generic meaning of a member-wise assignment in a class type is not acceptable when we have a pointer as a member. So here in fstack definition, P array is a pointer, so the memory is dynamically allocated and the address is stored here. So if you do assignment, the address is shared, so it causes a problem. So we have to redefine the meaning of assignment, not ending up sharing the same array, but actually copy the contents of the array. That's what you wanted. So we need to redefine meaning of the assignment operator. So operator overloading works in this case.